Have you ever really thought about our sense of smell? We're about to explore how we can give this ancient primal sense to an AI. And trust me, this isn't just about adding a new sensor to a robot. It's about fundamentally changing how a machine connects with the real, physical world.
So just take a second and think about that question. What if an AI could actually smell? We've given AI sight and hearing and even language, but smell? Smell is a whole different ballgame.
Our sense of smell is deeply, deeply hardwired into our brains. It's all about memory, emotion, and most importantly, survival. It's like a chemical truth detector. And for all of its incredible power, AI has been completely oblivious to this entire dimension of reality. Well, until now.
So, our first stop is understanding why this missing sense is so crucial. Think of it like this: a photo of a flower. It's just data. It's an abstraction. But the smell of that flower, that's the flower's actual chemical reality, right there in the air. This is all about grounding AI in the physical world in a way that's never been done before.
Okay, so how on earth do you teach a machine to smell? It sounds impossible, right? Well, the very first massive challenge is figuring out how to turn the physical world of molecules into digital code, a language that an AI can finally read and understand. It all begins with these things called volatile organic compounds, or VOCs for short. Seriously, every single thing you can smell right now, your coffee, the rain outside, anything, is just releasing a totally unique cloud of these microscopic chemical compounds. They are quite literally the alphabet of every scent in the world.
And the process of capturing that scent breaks down into 3 basic steps. First, an object releases its unique cocktail of VOCs. Then, those VOCs hit olfactory receptors, whether that's in your nose or in a machine. And finally, the specific way those receptors light up creates a one-of-a-kind digital fingerprint for that specific smell.
And what's wild is just how different perception can be. We humans, we have about 400 different types of these receptors, which gives us a pretty good but still limited view of the world. A dog, on the other hand, has over 1,000. It's experiencing a chemical reality that is so much richer than ours, it's almost unimaginable. So the goal here isn't to just copy a human nose, but to build an AI that can perceive smell beyond the limits of any single species.
So once we have that digital fingerprint, what do we do with it? We use this really cool method called vector space representation. The easiest way to think about it is like a recipe. This method turns that complex scent recipe into a simple string of numbers, a vector. And each number in that string represents the intensity of an ingredient, like how floral it is or how earthy. All of a sudden, a smell is just a math problem. And AI? Well, AI is really, really good at math.
This quote just nails it. If vision and sound are abstractions, smell might be the most truthful sense. A video of a campfire isn't the campfire, but the smell of smoke is the actual molecules from that fire hitting your senses. For an AI, this is a direct, unfiltered, truthful connection to the physical world. But okay, just being able to identify a smell is one thing. That's just step one. This is where things get really mind-bending. The real breakthrough happens when the AI isn't just reading smells from a database, but is actually learning, adapting, and evolving its own sense of smell, almost like a living creature. And that's the huge difference here. Traditional AI, it learns from these giant, static spreadsheets of data. It's powerful for sure, but it doesn't really experience anything. This new evolutionary approach is totally different. The AI learns by doing. It's placed in a simulated world and has to learn from its experiences, driven by a need to survive, just like any other biological organism. The way this works is by using tools that basically mirror biology. You've got genetic algorithms, which are like digital natural selection. The most successful smellers get to pass on their code to the next generation. Then there's reinforcement learning, which is a reward system. The AI gets a digital pat on the back when it correctly uses smell to find food, for instance. And all of this happens inside these incredibly complex simulated worlds where the AI can just live and learn and grow. So in the very beginning, at Generation 1, the AI is, well, it's pretty clumsy. Its accuracy for identifying different smells is only around 34%. But then, you let it run. And after 500 generations of evolution, of living and failing and succeeding in its little world, its accuracy just skyrockets to 97%. It didn't just get programmed, it learned. It evolved a sophisticated digital nose all by itself. Okay, so this is all incredibly cool, but why does it really matter? What's the point? Well, an AI that can smell with superhuman accuracy and learn from its environment, that could, and I mean this literally, change everything. The possibilities are just staggering. Just think about this for a second. We could have a rover on Mars that can actually smell for the chemical traces of ancient life. Or imagine a little device in your bathroom that could diagnose diseases just from your breath, years before you'd ever feel a symptom. We could monitor the health of entire ecosystems, or even discover brand new materials we've never even dreamed of. It's huge. And that gets to the big picture. Smell isn't just another feature you tack on. The thinking is that it could become the absolute cornerstone for AI systems that can finally understand our reality right down to the molecular level, right? And this, of course, leads us to some really profound territory. Because when an AI can learn and adapt its own senses based on a drive to survive, the line between what we call a machine and what we call an organism starts to get very, very blurry. This is where you start to see something fascinating called emergent behaviors. These are abilities the AI develops all on its own, things that no human ever programmed into it. They just emerge out of the sheer complexity of its learning, kind of like how intuition or instinct works in animals. For instance, the AI might start connecting the dots on its own, linking the smell of smoke to the sound of an alarm without ever being told they're related. Or it could learn to predict how a smell will travel through the air. It might even develop preferences for certain scents because it learned they lead to better outcomes in its world. It's not just calculating anymore, it's starting to reason. So when you have a system that can perceive its chemical world, adapt its own senses, and develop survival strategies, it really does begin to look less like a simple tool and more like a new kind of synthetic life. And that forces us to grapple with some really deep questions about what life even is. So here's one for you. Can a machine ever truly understand the comfort you get from the smell of your childhood home? Or is it just running an unbelievably complex pattern matching program? Where do we draw the line between a simulation of understanding and the real thing?
And what about our own blind spots? As we build this thing, how do we make sure it doesn't just inherit our own limited, human-centric view of the world? How do we set it free to perceive the vast chemical reality that we ourselves can't even detect?
Which leaves us with this final thought. If a system can perceive its world, if it can learn from its experiences, and if it can evolve to survive, where exactly does the machine end and where does life begin?